In this video, we're going to try a couple of methods to see if we can turn lava rock back into molten lava. Guys, we've got a fun experiment for you today brought to you by YouTube user Awesomeness Brahadish. I don't know if I'm pronouncing that right, but Awesomeness, you wanted to know if we could please melt rock. And today we are going to try that out. We've got a couple of different methods we're going to try to see if we can take some lava rock and turn it back into liquid lava. Here's the basic plan. We're going to try taking some lava rock, putting it in a crucible, and letting it sit in our foundry for a while to see if it gets hot enough to melt the rock. We'll also use the arc furnace to try melting some rock into lava, and if we get enough melted rock, we may try pouring it into sand to see if we can cast with it. As a first step, let's gather up a little bit of this lava rock from where Grant has some in his yard and see what happens if we throw it in the foundry. Lava rock. Oh my gosh, it's actually melting. Now, I did not think that this furnace was going to get hot enough to melt lava rock, but looking in the sides, I think it looks like it's starting to deform a little bit. That right there is some melted rock. It's not super liquid, but it's gooey. It's not running like a thin liquid, but clearly this is melted. I have a small piece of it that I scraped out right here. It's very glass-like. I don't really think it's going to get more liquid than that inside our foundry, so what I'm going to do is take the crucible out and see if we can pour or at least scrape the goo out from the inside of the crucible. Our lava has cooled down pretty quickly after we poured it out of the cup, and as you can see, it never really flowed very well. Let's let this cool down and take a closer look once we can touch it with our hands. We've got our mini arc furnace set up, and now I think it's time to see if we can melt this rock down into lava. Although it occurs to me, if we do melt it down into lava, it'd be nice to pour it out into something, and I don't just want to pour it on the table. So maybe let's grab a little bit of sand, make an impression in that, and then just in case this works really well, we can try pouring it out into the sand and maybe cast some lava. It's not the most advanced mold ever, but it's a shallow recess into the sand, and if we pour any lava into it, I suspect it'll hold. Holy cow, that right there is lava. It is liquid lava. Not all of it is liquefied at once, but that right there is rock just running around in there. All right, that's starting to cool off. I'm gonna turn this back on, try and heat up all of it enough that I can pour it out into the sand. When I do that, I'm gonna try and turn it off and throw it in there really quickly because it does start to cool down quite fast. Well, it doesn't go very quickly. And we're getting some funny shapes out of it. So this kind of lava rock is really not far off from being glass. Once it's melted down, what I'm making is probably more like obsidian than it is anything else, which is a very glass-like rock. So all of it didn't melt down into a nice, flowing, pourable liquid, but we did get melted rock. And while it was in there, that right there, that's lava. That is melted rock straight up. And it's gonna be really interesting to see what this looks like once it cools down. Right now, of course, it's still very hot. There's a good chance that it's gonna crack somewhat as it cools as well. Glass-like substances do that, but we'll see how it turns out. Wow, bottom of this brick, not even warm. That is amazingly insulated stuff. As the glass on the sand cooled down, I think it did fracture, and the force of it sent pieces flying a little bit. Just likes to crack as it cools off. If it cools off too quickly, like it just did, then it will break. Or it looks like something out of Venom, like that's one of his little tentacles reaching off. Very little, mini Venom. I'll try and break this. Hey, it broke. Let's try this again. Let's melt a little bit more. Also cools down pretty quickly. But it just goes from that lava rock pumice texture to just a straight glass texture in no time at all. Too hot. Just sent glass shards everywhere. Unfortunately, while it does get super hot, it only gets super hot in a pretty concentrated area. So it doesn't do a good job of melting all of it at once. One thing I can try though is I'm gonna put the lid on top of the furnace, get those leads really going, and hopefully it will just make a sort of oven inside there. That's the goal behind the lid in the first place. Starting to get hot, so I'm gonna take it off. As it was very melted in there, I was able to stick the screwdriver down in and play with it and stretch it out. And there's a chance that while this cools down, that will still crack at some point and just fall off. But I'm gonna let it sit there in case it doesn't. Well, just now I tapped very lightly on this and it fell into a few different pieces. It's too bad. Not very surprising though. The rocks that we started with are something called scoria, which is a type of igneous rock. Igneous rocks are those that are made from magma as it comes up out of a volcano or a split in the ground in between tectonic plates. Now this stuff, the scoria, is made when volcanic magma comes up out of the ground and rapidly depressurizes as it cools down. This type of rock actually has quite a bit of air bubbles in it, which form as the rock is cooling. Imagine the soda in this bottle as magma. It's under pressure right now because the lid is still on it. And as you know, there's carbon dioxide dissolved into the liquid, which stays dissolved as long as it's under pressure. However, as soon as we open the bottle, we lower the pressure on the liquid. And you can see that the bubbles form and come up out of the soda. All of those bubbles started coming up out of the liquid because under lower pressure, the liquid doesn't dissolve as much of the gas. Underground, magma is under pressure and it has some gases dissolved in it too, like H2O and CO2. When the magma comes up onto the surface, a couple of things happen. First, it starts cooling off because it's a lot colder up here than it is down under the ground. But it also loses pressure and that lowers the solubility of the gases in the magma. So all of that H2O and CO2 starts to undissolve from the magma and then it starts to expand because it's under lower pressure. But it's also cooling down and then it gets trapped inside the cooling lava to form our little rock. The reason we're not getting this same effect when we melt it is we're melting it under normal pressure. There's no additional dissolved gases in there, and in fact, some of the dissolved gases escape as we melt it down. That's part of the bubbling action that we see as we melt it. Once it's all melted though, no more gases are coming up out of it as it solidifies, and so it just forms a hard, smooth glass. It's actually quite impressive how black, smooth, and shiny this forms. Let's go see if the stuff we poured out of our furnace is cool enough to handle. So this stuff was not able to melt quite as completely as the stuff we hit with the arc furnace. The arc furnace does definitely get hotter than our foundry. What we have here is somewhat more glassy than the original rock we started with, but it doesn't have the smooth, pure black texture of what we melted in the arc furnace. You can still see some air bubbles in there, I think, and some of those may have already been there when we started melting the rock, and some of them may have formed as I tried to scrape it out of our crucible. It's an interesting texture. It's actually very similar to the rock that we started with. It's just maybe a little more fragile, and of course a different shape. Well, awesomeness, Braha Dish, thank you for your suggestion to try and melt rock. Check your YouTube inbox, we're sending you $25. And guys, remember, if you come up with a cool idea, let us know down in the comments. And if we use your idea to make a video, we will send you 25 bucks. Guys, that is not all we've got. More for you to see. That box up at the top will take you to our last video. If you haven't seen it yet or need to watch it again, click now. The box at the bottom will show you what YouTube thinks you need to be watching next. This bomb here in the middle will subscribe you to the channel, and that way you'll never miss a video. Don't forget to ring that bell so you definitely get the notifications, and we'll see you in the next one. Talk to you then.